A very informative morning to all viewers. This talk is all about basically the brief explanation about topological insulator and topological crystalline insulator. This presentation will be summarized under some outlines. First is basically what is topology. Second, what is topological insulator and its physical connection. Third, how topological insulator works. Fourth, role of Kramer's degeneracy in topological insulator. Spin-orbit coupling, time reversal symmetry, wave function, topological crystalline insulator, and how they are different from topological insulator. Application. First, what is topology? Topology is basically a mathematical term which deals with the systems under some continuous deformations under some invariant conditions like stretching, twisting and bending, but never gluing or tearing. So there are two examples, coffee cup and donut. They are in the continuous deformation states, so with y protected by the genus n equal to 1 and calculated surface area with the Gauss Bonnet theorem, so this equals to 0. And this is the example of the sphere in which genus is equal to 0 and calculated by mathematical interpretations with the physical, and this states that the surface area is equal to 4 pi and with G is equal to 0, so we applying here in the Gauss Bonnet theorem, so this also states this is equal to 4 pi. So the Gauss invariant theorem is applying here, and this states that the surface is equal to surface area of the sphere is equal to 4 pi. So Gauss invariant theorem in the physical interpretation. So this is the vector potential here, and this is the curvature of the billion zone, and with the calculation of the billion zone, this states that n, which is a Chern number, and this is in physics this is known as Chern number, and in mathematics this is known as the genus. And this example states that the surface area is equal to 4 pi under the Gauss Bonnet theorem, and they are in the same homomorphic class with genus n equal to 1 and surface area is equal to 0, and these three are in the different class with genus g equal to 0 and surface area is equal to 4 pi. So these are in same homomorphic class with g equal to 0, and these three are in the same homomorphic class with g equal to 0. So topology in physics. Topology in physics, in condensed matter physics, this deals with the topological insulator and topological crystalline insulator. What is topological insulator and its physical connection? Topological insulator are those materials which have surface conducting but bulk is insulating. At the surface, electrons are very rapidly high moving electrons with very high speed, and many physicists claim that they are the continuous band deformation of the in topological insulator are so rapid there is no uncertainty up to the level of the Heisenberg uncertainty. Topological crystalline insulator, these materials are protected by crystal symmetry, but many times these are protected by mirror symmetry and inversion symmetry instead of time reversal symmetry, which is also part of the crystal symmetries. And topological insulators and crystalline insulators band deformation, ballast band to conduction bands are so rapid band deformation. The many physicists claims that there is no uncertainty in the band deformation up to the level of the Heisenberg uncertainty. And these are some examples in topological insulator, and these are some examples of the topological crystalline insulator. So in billion zone topology deformation. So PBT is a material which is a trivial material and not a topological insulator, so there is no continuous deformation in the bands. SNT, which is a topological crystalline insulator, so there is a continuous deformation in the bands here shown here at a certain L point, and similarly there are 4 L points in SNT materials at which there are a continuous deformation. The high symmetry points may shift or change, undergoes the deformation of the billion zone, but shape or size with different shape or size, but the energies between bands are remain finite due to the overall conservation of the band structure is preserved here. So as long as the band structure is preserved, so long as the topology remain finite in the system. High symmetry points shifts so long similarly to the band diagram change, but the energy remain finite in the band diagram. Topological insulator along with the topological crystalline insulator. Role of Kramer degeneracy, spin orbit coupling, time reversal symmetry. So these are the band diagram of the topological insulator. The up edge states and this is the down edge states, and the up electrons in the upper band with right movers and down electron in the down band with the opposite movement. So as long as the electron change the direction of the spin, so long as the change the direction of their momentum. So we are coming on the point is that the Kramer degeneracy in the materials. These are the Kramer doublets. This means that yellow one and blue one, these are the two eigenstates, but energy is same here, and the electron can either reside in blue state or either in the yellow state. But at a certain time there is only one electron here, and as the electron change the direction of their spin, also change the direction of the momentum on the other hand side edge states. So if at one edge state spin is up, then at another edge state spin is down with opposite momentum. If spin change the direction of the motion, also change the direction of their spin. So this shows the Kramer degeneracy. And again this states that there are two levels, but electron can either reside in one level with either the spin up or down. So this was the Kramer degeneracy, and the spin orbit coupling is here basically states that as the electron change the direction of their spin, also change the direction of their momentum at the other end. So if on applying the symmetry operations of over the Hamiltonian, so as long as the Hamiltonian come out with the symmetry operation, so long as the topology is preserved, as has been wrote with the red one, as long as H is conserved, so long as the topology preserved in the system. And time versus symmetry states that as the electron change the direction of their momentum, also change the direction of their spin. So this is also preserved by the uh, time result symmetry. And bulk gap is insulator because these are the materials designed in such a way that there is the induced internal magnetic field which create the cyclotron orbits inside the material. So the bulk is insulating in these materials. Topological crystalline insulator. This is the symmetric diagram of the topological crystalline insulator protected by the mirror symmetry, and many times it is protected by the band inversion symmetry. So this is the combined form of the mirror symmetry and band inversion. And this is different basically from the topological insulator because this is protected by the crystal symmetries. And this states that the mirror chain number states that the electrons with the chiral symmetries, and there are the four L points similar to L1 and L2. There are the four L points in the topological SNT materials which state the at four different L points they are preserved by the mirror symmetry, and the other chiral states have been shown here, and this state that the L1 and L2 the spin with the chiral symmetries. So this is preserved by the uh, chiral mirror symmetries here. And this is the topological crystalline insulator, which is basically different from topological insulator. So this is the animated view of the topological insulators. Band structures are equivalent if they can deform into one another without closing the energy gap. So this is the example of the football under stretching. There is a continuous deformation, and this is protected n equal to genus equal to 0, and surface area is equal to 4 pi. And this is the band diagram of the topological insulator. There is a continuous deformation, valence band to conduction band to valence band, and physicists claim that the deformation is so rapid So there is no uncertainty up to the level of the Heisenberg uncertainty, and eigenstate. This shows that the energy is same here. So this is known as the Kramer degeneracy because there are the two levels, but energy in both equals to 1. So electron can either reside blue one and yellow one, but as the electron change the direction of their spin, also change the direction of their momentum. So this is also the concept of the time universal symmetry, and as long as the time universal symmetry preserve the Hamiltonian, so long as the topology preserved in the system. These are the wave functions which are continuously also in the deformation states, and total probability of the wave function in the topological insulator is up to 16. So how trivial system change to topological insulator? So in trivial system there is a large band gap, so the electron cannot move to conduction band to valence band, and in dark electrons only a certain dark point the conductivity is there, and as it goes into the topological insulator the surface is conducting but there is a band gap in the bulk. So basically these are the materials designed in such a way that there is an intrinsic magnetic field and cyclotron radius inside the materials, and there is no conductivity by the bulk. And trivial insulator example, and this is the example of the topological insulator. There are continuous deformation in the bands, and in bulk there is band gap, but at the surface is the conducting with very high rapid electrons. Application of the topological crystalline insulators without applying the external electric field. So there is no polarization of the dielectric materials of the spins of the TCI materials, and this is the on state. But when we are applying the electric field, the all the TCI electrons are parallel to the electric field direction. So as the electron parallel to the electric field direction, so there is the mirror symmetry broken, and due to the broken of the mirror symmetry there is a gap, and which is the off state. On applying gate bias voltage, the dipoles within dielectric materials polarize perpendicular to the TCI film, so TCI electrons polarize in the direction of the electric fields, due to which mirror symmetry has been broken, and due to the broken of the mirror symmetry uh, uh, there is a band gap, and this shows the off state. Then this is the space-time topology. A planet is all moving around the sun, and space-time is distorted, and there is a continuous deformation here. So thank you.